Welcome friends. In this video, I am going to discuss about the infinite series, all the basic definitions of infinite series, and in next video, I am going to discuss the for infinite series convergent and divergence of the Cauchy's root test and D'Alembert's root tests. Okay. First of all, let me give the basics, all the basic definition related to this infinite series. First, what is infinite series? If un is a function of n, if it is a function of n defined for all integral values of n, an expression of the form u1 plus u2 plus u3 and so on up to un containing infinite number of terms is called infinite series. The sum of all the terms in the sequence is known as nothing but infinite series and is denoted by summation un simply, or summation n equal to 1 to infinity un. And here un is called the nth term of that particular series. Next, some basic definitions. What are the terms I am going to use here is, if un, each term is greater than or equal to 0, each term is positive for all n, then it is known as positive term series. And in this module, in this video and throughout this infinite series, we are going to discuss only the positive term series here. Next, if all the terms are 0 after some terms, then un is known as a finite series. That means if that series is containing finite number of elements, then it is known as a finite series. Okay, usually we are discussing infinite series only here. If Sn represents the u1 plus u2 plus up to un, first n terms, sum of first n terms, okay, sum of first n terms, then Sn is known as nth partial sum of the series. Next, a series un is said to be convergent, important here, converging to some number, okay, convergent if limit as Sn, first n terms, as n tends to infinity means infinite terms, sum of first infinite n terms is equal to L, a finite quantity. If L is a finite quantity, then we say that it is convergent. Like that, if a series un is said to be divergent if limit as n tends to infinity, Sn is equal to plus or minus infinity, it may be plus infinity or minus infinity, then we say it is a divergent series. Like that, a series summation un is said to be oscillatory if limit as n tends to infinity, Sn is equal to 2 or more values, it is equal to finding finite only, but it tends to 2 or more values, then we say it is a oscillatory series. Okay, like that, some more definitions I am giving here. Properties of infinite series. What are these properties? The nature of the series, that is convergent or divergent of the series, remains unchanged if the sign of all the terms are changed. If you are changing the signs positive to negative, negative to positive of all the terms, then it is remains unchanged. Either it is convergent or it may be divergent. Like that, the addition or removal of a finite number of terms is done, then also the series, nature of the series will remain unchanged. Like that, each term of the series is multiplied or divided by some finite number m which is not equal to 0, then also it is the nature of the series will remain unchanged. Like that, if series un and series vn are convergent, then the addition of two series is also convergent. And if a series un and vn are divergent, then the sum of this also divergent. These are some few properties what I am to discuss here. Next, some examples I will give you. What are the series what was studied previously? That is arithmetic progression. We know that arithmetic progressions that is given by, that is series or sequence, arithmetic sequence is given by a comma a plus d comma a plus 2d and so on. This is known as arithmetic progression. Then nth term of this progression is given by un is equal to a plus n minus 1 into d. And the sum of first n terms Sn is given by n by 2 into 2n plus n minus 1 into d. Or if the last term is given, then Sn is given by sum of first n terms. Sn is given by n by 2 into bracket a plus l, where l is the last term. Like this, geometric progression I am going to discuss here. That is here geometric progression I want to discuss here. Let a plus ar square plus ar cube and so on be the geometric series with first term as a and common ratio ar divided by ar square divided by ar is equal to r. The first term is a and the common ratio is, then the nth term is given by un is equal to a into r to the power n minus 1. And sum of first n terms, very important, sum of first n terms is given by Sn is equal to a into bracket 1 minus r to the power n divided by 1 minus r for r less than 1. If the common ratio is less than 1, then this is the sum series. And if Sn is equal to a into bracket r to the power n minus 1 divided by r minus 1 for r greater than 1. If r common ratio is greater than 1, then I can apply this formula. Therefore, let me discuss the nature of this series when it is convergent and when it is divergent. Here, the modulus of r is less than 1, that is common ratio is less than 1. Then here r to the power n, if say for example less than 1 means 0.5 it is there. If its a square will become 0.25. Again its a cube will become 0.10125. Like that, as the n increases, the power increases, it tends to a smaller number. Therefore, r to the power n tends to 0 as n tends to infinity, provided r should be less than 1, then only r to the power n tends to 0 as n tends to infinity. Then what happens to this limit then? Limit as n tends to infinity, Sn is equal to, as less than 1, first condition I have to take, limit as n tends to infinity, a into bracket 1 minus r to the power n is 0 divided by 1 minus r. Therefore, a divided by 1 minus r is a finite quantity. Therefore, a geometric series is convergent for modulus of r less than 1. Similarly, if r is greater than 1, then what going to happen here? If r is greater than 1, r to the power n is tending to infinity. If r is greater than 1, 2, 3 like that, then it is tending to infinity as n tends to infinity. Therefore, limit as n tends to infinity, a into r to the power n minus 1 divided by r to the power n is tending to infinity. Infinity minus 1 is again infinity. Infinity into something is also infinity. Therefore, it tends to positive infinity. Therefore, a geometric series is divergent for n greater than 1. If n is less than 1, it is convergent. If r is greater than 1, then it is divergent. Like that, some more examples I would like to discuss here. That is, test the convergence of the series. The series is 1 divided by 1 plus 2 plus 1 divided by 2 into 3, 1 divided by 3 into 4, like that terms as given. And here nth term they are not mentioned. I have to find out that nth term. For n equal to 1, 1 divided by 1 into 2. For n equal to 2, 1 divided by 2 into 3. For n equal to 3, 1 divided by 3 into 4. 3 plus 1. Therefore, nth term I can write it as 1 divided by, here nth term un is given by 1 divided by n into n plus 1. First term into its next term, that is n into n plus 1. Using partial fractions, I can write it as, or you can take LCM here, n into n minus 1. This will become n by n plus 1 minus n. n cancels. Therefore, this is my partial fraction. I can write like this term. Okay. Therefore, sum of first n terms, what is going to happen? That is Sn equal to first term 1 divided by 1 minus 1 by 2 plus, this is my first term. Second term for n equal to 2, 1 by 2 minus 1 by 3. Next, third term will become 1 by 3 minus 1 by 4, like that. Nth term will become 1 by n minus 1 by n plus 1. Therefore, minus 1 by 2 plus 1 by 2 cancels. Minus 1 by 3 plus 1 by 3 minus 1 by 4 plus 1 by 4 cancels, like that. 1 by n minus 1 by n previous term cancel, only minus 1 divided by n plus 1 will remain. Therefore, my Sn is equal to 1 minus 1 divided by n plus 1. Therefore, limit as n tends to infinity, Sn is equal to limit as n tends to infinity 1 minus 1 by n plus 1. n is equal to infinity. Okay. Therefore, 1 minus 1 by infinity. 1 by infinity is a 0. Therefore, 1. It is a finite quantity. Therefore, the summation un, that is a series un, is convergent and it converges to 1 here, the value of 1. Okay. This is limit as n tends to infinity Sn, whether it is finite or infinite I am calculating. Then I can evaluate this. Okay. Like that, 2 more examples I am going to evaluate here. Okay. Next example is show that 1 square plus 2 square plus 3 square and so on diverges to infinity. I have to show that. Here Sn is sum of first n terms. This is I will not derive and all those things. I will just include 1 square plus 2 square plus 3 square and so on up to n square if it is given. Sum of first n terms is given by n into n plus 1, 2n plus 1 divided by 6. All these things, derivations were done using mathematical induction method. So I am assuming from that Sn, like that, first sum of first natural numbers 1 plus 2 plus 3 and so on up to n is given by n into n plus 1 divided by 2. Like that, 1 square plus 2 square plus 3 square up to n square is given by n into n plus 1 divided by, 2n plus 1 divided by 6. Taking the limit as n tends to infinity for this, limit as n tends to infinity, n into n plus 1 into 2n plus 1, as substituting n equal to infinity here, infinity into infinity, infinity plus 1 is again infinity, infinity into 2 is again infinity plus 1 is also infinity. Therefore, infinity into infinity also again it becomes infinity divided by 6. That is divided by 6 also will become infinity. Therefore, series un is equal to series n square is divergent. It is tending to plus infinity here. Therefore, it diverges to plus infinity. Okay, like that. Last example I am going to solve here is test the nature of the series summation n equal to 1 to infinity minus 1 raised to n. Minus 1 raised to n is expressed as minus 1 plus 1. For n equal to 1, it will become minus 1 raised to 1 minus 1. Next, for n equal to 2, this will become minus 1 raised to 2. Okay, minus 1 raised to 1 plus minus 1 raised to 2 plus minus 1 raised to 3 plus so on. Minus 1 raised to 1 will become minus 1. Minus 1 raised to 2 will become plus 1. Therefore, it is plus 1. Minus 1 raised to 3 will become again minus 1. Therefore, minus 1. Minus 1 raised to 4 will become again plus 4. Plus 1. Like that. For even numbers, it will become plus, and for odd numbers, it will become minus. Therefore, sum of the first n terms is equal to minus 1 plus 1 cancels. If it is even number, therefore 0. If it is odd number, minus 1 plus 1 cancels, minus 1 will remain. Therefore, it is odd. Here limit as n tends to infinity if you are taking, and Sn will become a finite, but it is not unique. Either it may be -1 or 0. Therefore, the series is oscillatory here, we can say. Like that, in the next video, okay, here they are simple. I am solving like this. In the next video, Cauchy's root test, examples on that, and D'Alembert's ratio test I am going to explain in my next video. Cauchy's root test, okay, and examples on this. Okay, please subscribe my channel and give the comments. Also, don't forget to hit the like button. Thank you, friends.